Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about Postgres log conflicts on Amazon Aurora. We'll also talk about tuning Maxstandbystreamingdelay and hot standby feedback. In this blog post by Wanda and Avi from the AWS team, they talk about how Amazon Aurora differs from regular RDS Postgres, and they describe how you have to watch out for log conflicts that can cause query cancellations on readers. To start with, they describe the architectural differences between Aurora and RDS. If you have a multi-EC setup on RDS, each node has its own independent storage. On Aurora, on the other hand, each node also has its own cache, but then the actual data on disk is shared between the nodes. This also enables Aurora's capabilities to quickly launch new readers. This blog post talks about the downsides of this architecture, and it has to do with handling conflicts between the different states of these nodes. Imagine you have a DML operation on the primary. This operation generates transaction log records or WAL in Postgres. And so this has to be sent to all the reader nodes to then synchronize the caches of these nodes. When a reader does not have the page in the cache, it can actually ignore that, because if it was to be accessed, it can access the shared storage. And so that is always kept in sync between the nodes. When you have a query that's currently running on either the primary or the reader node, they can hold locks on pages. In this post, they talk about log conflicts, amongst other things. They generate some test data, and then they have a statement here. When you run it without any conflict, it will finish in 72 seconds, no problem. Now, they do produce a conflict. They start this query on a reader, and then on the primary, they drop the index. When you drop this index, it will actually cause the reader to cancel its statement. This is an issue that can also occur in regular Postgres. There are a couple of Aurora-specific things to understand. So early in this post, they do describe Maxstandbystreamingdelay. First of all, Aurora does not give you the option to turn that off. You can tune the setting, but you can't set it to higher than 30 seconds. The other thing to understand is that if Aurora encounters a problem where there is a conflict between the reader and the data that's coming in from the primary, it will wait for up to 60 seconds. That's a second internal timeout. And after those 60 seconds, Aurora will actually take the action to restart the reader node. If you see a reader node restarting because you have a lot of conflicts, this is why. This is Aurora's mechanism where it makes sure that it doesn't have the cache diverge for more than 60 seconds from the primary. They do talk about a few ways how to address these issues on Aurora. First of all, they do generally recommend that reader queries should try to be finished before that Maxstandbystreamingdelay setting is hit. For example, look at missing indexes or implement table partitioning. This matters even more in Aurora, and it matters even more in an Aurora reader, because that helps you avoid these conflicts. They do recommend to implement retry logic. If cancellations occur, oftentimes if you rerun the same query, it will succeed because the issue on the primary has stopped appearing. And so if you rerun the query, even if it's longer than 30 seconds, it will most likely succeed. Retry logic is important with Aurora. The other thing that I mentioned here is the fast cloning feature. Fast clones avoid all these conflicts. In general, this is something that's not just happening on Aurora. Query conflicts can happen on a regular Postgres stream replication setup. The Postgres documentation does describe a few other aspects that are good to understand. For example, they do mention here that when you have tables that are regularly and heavily updated on the primary, then you will often see cancellations of long-running queries. If you have a heavily updated table, then you may actually want to shift your read queries away from the readers to the writers, because that way you avoid the log conflicts. The other thing that the documentation mentions here is called the hot standby feedback setting. Hot standby feedback is actually always enabled on Aurora, but on other Postgres installations, you may choose to turn it off. It tells the primary that the secondary is still using certain parts of the table, and when there's a vacuum process, that vacuum process will actually skip over those rows that are still being used by the secondary. It has the benefit of avoiding log conflicts, but it has the downside of potentially causing table bloat. This is actually something you should be aware of in Aurora, which the AWS blog post did not talk about. Because they have hot standby feedback turned on, it's possible that vacuum doesn't do its work effectively on Aurora, and then you'll see table bloat occurring. The other thing I want to mention is how Twitch uses Postgres. This is a blog post from a few years ago. One of the things they talk about here is that sometimes they have data scientists or analysts running ad hoc queries. in order to be able to do that effectively, what they've done is that they have readers that have hot standby feedback turned off and max standby streaming delay set to 6 hours. And so that means the secondary will queue up the wall. If there's a conflict, it will just wait with applying the wall for up to 6 hours. And it will also not tell the primary that there are active queries on the secondary and thus not cause bloat. This is a great configuration of regular Postgres to make sure that your secondaries can be used for queries. But again, this will then increase the replication lag, which is something that you want here. On Aurora, this is a perfect use case for a fast qual. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode and talk to you next week.